this is your Kalpana here. In this video, we are going to do some problems on limits. Okay, so let's start with the first one. So first problem, let f of x equals to cos x if x greater than 0 and x plus k if x is less than 0. So here, find the value of constant k. So we have to find the value of constant k given that limit f of x exists. Okay. Solution. So given f of x is defined by cos x if x is greater than 0 and f of x equals to x plus k if x is less than 0. If we consider a real line, suppose this is a point 0. If x is greater than 0, if x is greater than 0, that is towards right side or right from 0. F of x equals to, for x greater than 0, we'll have f of x equals to cos x. If x is less than 0, we'll have f of x equals to x plus k. Okay. And also given that limit x tends to 0, f of x exists, which is nothing but limit x tends to 0 minus f of x equals to limit x tends to 0 plus f of x. Okay. So using this condition, we have to find the value of the constant k. Okay. So this implies limit x tends to 0 minus. So here we'll replace x tends to 0 minus with h tends to 0 and f of x can be replaced with 0 minus h, which is equals to right hand limit. Limit h tends to 0. Again we'll replace x tends to 0 plus 2, h tends to 0 and f of will replace x with 0 plus h. Okay. So when x is less than 0, f of x is x plus k. F of x is x plus k. So this implies x, once again, limit h tends to 0, x plus k equals to limit h tends to 0. For x is greater than 0, we'll have f of x equals to cos x. Cos x. Okay. So in the place of x, we'll replace 0 minus h here. And in the place of x, we'll replace 0 plus h. Okay. Now, putting h equals to 0, this implies if you'll substitute h equals to 0, you'll get 0 minus 0 plus k equals to cos of 0 plus 0. So this equals to, this implies k equals to cos 0. Since cos 0. Value of cos 0 is 1. So this implies k equals to 1. So therefore, k equals to 1. Since we have used the condition which is given that limit f of x exists. So we are given the condition that limit x tends to 0, f of x exists. So using this condition and the definition of f of x, we got the value of k which is equals to 1. Okay. So now coming to the second question. Second problem. Let f of x be a function defined by f of x. So given f of x equals to 4x minus 5 if x is less than or equals to 2, and f of x equals to x minus lambda if x is greater than 2. So now we have to find lambda if limit x tends to 2, f of x exists. Okay. Solution. So consider a real line and let it be 2. This is the point 2. Say for x less than or equals to 2. For x less than or equals to 2. If 2 lies towards left. X less than or equals to 2. Since they have given not strictly less than, they have given less than and equal to 2, which is nothing but this includes 2 also. F of x equals to 4x minus 5. And if x is greater than 2, if x is greater than 2, that is not including 2, but it is greater than 2. X is strictly greater than 2, then f of x equals to x minus lambda. Okay, fine. So let's find left hand limit. Limit x tends to 2 minus f of x, which is equals to, now replace x tends to 2 minus by h tends to 0 and x by 2 minus h. Okay. So limit h tends to 0. F of, now replace x by 2 minus h. Okay. So when x is less than 2, we'll have function 4x minus 5. So this is equals to limit h tends to 0, 4 into x minus 5. So in the place of x, you have to replace 2 minus h. So this is equals to limit h tends to 0, 4 2s are 8 minus 4h minus 5, or else you can write the same. Okay, now putting h equals to 0, you'll get 4 into 2 minus 0 minus 5. So this is equals to 4 2s are 8 minus 0 minus 5. So 8 minus 5 is 3. So therefore our left hand limit is equals to 3. Therefore limit x tends to 2 minus f of x equals to 3. Now we'll find the value of right hand limit. Limit x tends to 2 plus f of x. So now replace x tends to 2 plus by h tends to 0 and x by 2 plus h. Limit h tends to 0, f of, now replace x with 2 plus h. So this is equals to, when x is greater than 2, we have f of x equals to x minus h. Okay. So this is equals to limit h tends to 0, x minus h. Okay. So in the place of x, we'll replace 2 plus h. Now, putting h equals to 0, we'll get 2 plus 0 minus 0. Sorry, this is lambda. We are having x minus lambda, right? So if you put h equals to 0, you'll get 2 plus 0 minus lambda. So this is equals to 2 minus lambda. So the value of right hand limit is limit x tends to 2 plus f of x equals to 2 minus lambda. Okay. Now let's take the question. So find lambda if limit x tends to 2, f of x exists. So if limit x tends to 2, f of x exists, then limit x tends to 2 minus f of x equals to limit x tends to 2 plus f of x. Since we are having the values of left hand limit and right hand limit, this implies 3 equals to 2 minus lambda, or you can write it as 2 minus lambda equals to 3. So if you will take lambda to right hand side, you'll get 3 plus lambda. Now get this 3 to left hand side, then you'll get 2 minus 3 equals to lambda. Since lambda equals to 2 minus 3, 2 minus 3 is minus 1. So therefore lambda equals to minus 1. So finally lambda equals to minus 1 if limit x tends to f of x exists. So this completes the second problem. Okay. So this is all for now. Hope you will understand. If you have any doubts, just leave your comments below. See you in the next video. Until then, bye bye.